So hey everyone, so basically in today's GFG POTD we have to solve a problem juggler sequence. So basically in this problem it is saying that juggler sequence is a series of integer in which the first term starts with a positive integer number a and the remaining terms are generated from the immediate previous terms using the below recurrence relations. Okay, so this is really very easy question and we can solve this problem. Basically in this question we have to form a sequence, and how we can form the sequence. Actually here we have actually a one number given here, that means the first number, and we have to create the next sequence of the numbers by using its previous number. So how we can create this thing? By using this formula. If it is an even, then we have to use this formula. If it is an odd, then we have to use this sequence for generating our output. So for example, as it is given here, given n is equal to 9, so we know very well that n is odd. So according to this sequence, we can form a number like that. Let's suppose it is 9 and this is our first term, so it is odd, so we have to form a sequence by using this formula, and that means 9. And if we are saying that 3 root of 3, then we can say that cubic root of 9, we can say that it is 27, and 27 is also odd. So if I'm saying cubic root of like 27, so we can say that 140, and 140 is even. So if we are saying that root of 140, that means 11 something. Okay, and 11 is also again odd, so we have to form our next sequence by using this formula, that means cubic root. Okay, so we get 36. 36 is now even. Now for using this we get like 6 to the under root 36, that means 6, and again 6 is an even number, so if we are saying that under root 6, okay, that means it is something 2 point something, so it is 2. But again if I'm saying 2 is even, and again if I'm saying that under root 2, that means 1. So that's the thing, we can form this problem or form the sequence. So basically we have to repeat this process until it will not become 1. So how we can do these things? Like for example, the second example is given here, like n is equal to 6. We know very well that n is actually an even number, so we know very well the root under root of 6 is what, like 2 point something, so it is 2. 2 is now even number, so and again under root 2 is like 1, so we got 1. That's the sequence formed. Okay, so we have to solve this problem with an expected time complexity order of n and expected auxiliary space order of n. Okay, so for solving this problem, what I can do here, basically first of all I need to create a vector for storing the sequence. So I'm creating a vector. Okay, and let's say I'm saying here, and now what I can do, I need to take a previous value which basically stores the value so that we can decide the next value of it. So int previous is equal to, let's say I'm saying n. Okay, and what I can do, basically I need to traverse through the complete sequence. Okay, so while prev is not equal to 1, because we have to form a sequence until it will not reaches at 1, until we have to repeat the process. So we can say that inside it, that if previous modulo 2 is not equal to 1, that means if n is equal to, and if n is actually an odd number, then we need to form like this sequence. So we need to define this formula for this particular condition. So I can say that answer the push back, then we can say that we can use sqrt, then square root of power of we have like previous, which basically stores the value, and we are saying cube. Okay, that's all. And if it is an even number, then we can say that, else we can simply define answer dot push. We can simply use sqrt of previous, and again what I can do basically here, I need to store the value of like previous, no, so dot back, we can use previous here because we want to return our previous value, and simply we can return our answer here. Let's check the problem. Okay, so basically I need to store this value inside the previous. So it's working. Let's submit it. So yeah, that's all for the today. Thanks for watching.